This video has the answers to bookwork page 502, number 42, 44, 45, and 47. So I'll read the question and then you can pause it, try it out, and then when you resume it, I'll do the answer. Number 42 states, if the distance from a location to a charge is doubled, what happens to the magnitude of the electric field produced by a charge at that location? To do the answer to this, we need to look at the equation for electric field strength due to a point source, and that's E equals K Q over D squared. And by looking at this equation, what we can see is that if we change the distance by a factor of 2, we can get our answer. The electric field is proportional to 1 over the distance squared, which is like saying it's proportional to 1 over doubling that value squared, so it's proportional to 1/4 the value. So the electric field decreases by, decrease to 1/4 of the original value. Number 44 states, what is the magnitude of the electric field at a point 0.25 centimeters away from a point charge of 2 microcoulombs? So again, we're trying to find the magnitude of an electric field knowing something about a charge. Our basic equation is E equals K Q over D squared. And we have Q and D, but we have to be a little cautious because Q is 2 times 10 to the negative 6 coulombs. I need to do a conversion. And D is, we can't use centimeters in this problem, so we have to do 0.25. We're going to go 0.0025 meters. Move it over 1, 2 places to the left. And then the numbers, I'll plug them in. K is 9 times 10 to the 9th, and Q is 2 times 10 to the negative 6, divided by 0.0025. That equals, I'll do my calculation, 2.6 divided by 0.0025. Forgot to square the bottom, very important. A value of 2.88 times 10 to the 1, 2, 3, 4, 5, 6, 7, 9 newtons per coulomb. Number 45. At what distance from a proton will the magnitude of the electric field be 1.0 times 10 to the negative 10 to the 5 newtons per coulomb? So again, E equals K Q over D squared. Only this time we're looking for D. So D equals, I'm going to multiply both sides by D, divide by E, take the square root, K Q over E. The numbers that go in are 9 times 10 to the 9th. The charge of one proton is 1.602 times 10 to the negative 19, divided by the electric field strength, which is 1 times 10 to the 5. Equals, let me do this out. 1.602 19. I get a value of 1.2 times times 10 to the negative. Got a value of, for my little writing error, 1.2 times 10 to the negative 7 meters. Finally, number 47. What are the magnitude and direction of a vertically oriented electric field that would just support the weight of a proton, of an electron? To do number 47, the first thing we have to do is just kind of visualize. We'll start with the proton. Making marks on the screen. Proton, you have its weight, and then we want that to equal the electrostatic force. So what we know with the proton is the electrostatic force has to equal the proton's weight. And to calculate the weight of something, that's just its mass times the acceleration due to gravity. And the electrostatic force can be calculated if we look at the electric field strength, that equals F divided by Q. So if we rearrange that, F equals Q times E. So we're going Q times the electric field strength equals M times G. Q being the charge of the proton, E being the electric field strength that it's in. So if we solve for E, it's mg divided by Q. And we know all those numbers. We know that the mass of the proton is 1.672 times 10 to the negative 27. G is 9.8 on Earth. And the charge of the proton is 1.602 times 10 to the negative 19. And I'm going to do a little calculator work here. Divided by 1.602. And I end up getting 1.02 times 10 to the negative 7 newtons per coulomb. And it asks for the direction of the electric field. The problem asks for the direction of the electric field. And protons follow electric field lines, so this electric field line should point up. So it should be upward. That box there. This is for proton. For the electron, we're going to follow the same idea. You have the weight of the electron, the electric force. The electric force has to equal its weight. That's Q times E. That equals mg. So the electric field strength is just mg divided by Q. The numbers that go in, now the mass of the electron is 1.019 times 10 to the negative 31 times 9.8 divided by negative 1.602 times 10 to the negative 19. That value is going to be, get to calculating, divided by 1.6. That one is negative 5.57 times 10 to the negative 11 newtons per coulomb. And the interesting thing about electrons is that they will feel a force opposite field line, so the electric field should actually point down as opposed to up for the proton. The electric field should point downward for the electron if you want an upward force. And that kind of is seen by the negative value. Which once we have the downward, we can just kind of take out this negative and just think of it as an absolute value, and then we write a direction. So there are your answers to number 47.